Today's lesson comes from section 3.2, Measures of Variation. Let's do some reminders from the first chapter. A population is a whole. You have everybody or everything. Okay, so if we were talking about this class, that would mean every student that's in the class. Sample means part. You don't have every person or everything. Okay, what does it mean to vary? We're talking about measures of variation. My light bill varies. That means it changes. From month to month, it's different. It's not the same every time. Variation is talking about how data differs amongst themselves. If a teacher gives a test and wants to see how the student scored, first, you might find an average. Add up all the grades and divide to see what the average test grade was. Now, that gives some information, but that's not a lot of information. The teacher could then find the variance. The variance represents the average of how close each student was to the average. Okay, for example, let's say the class average was a 90 and you scored a 95. 95 minus 90 means you scored 5 points above average. Okay, we're seeing if the students did about the same. Is there a wide variety of scores? We're talking about how close together the numbers are. If you found the variance of the ages of people at a high school reunion and then did the ages of people at an NFL game, the reunion would have a smaller variance. Why is this? People at a high school reunion are usually close together in age. Okay, most everybody is close to 18 years old when they graduate high school. So most everybody at a high school reunion would be about the same age. Okay, the only variation would be students that maybe married somebody very different in age. Okay, if you looked at the variance of people at an NFL game, that would be a wider variety, okay? Because there could be all ages, ranges from a baby to any age, okay? There will be a bigger variety. There are several ways that we can measure how numbers vary. First, the range. The range means to take the highest number minus the lowest number. Okay, and that's the range. The second one would be a population variance. It's a measure of how close each number is to the mean for a group. Okay, remember that population means all the data. So population variance measures how close each number is to the mean for the group, finding the difference between a certain number and the average. Population means you have all the data. Okay, we're still talking about how close the numbers are together. The symbol for the population variance is the Greek letter sigma squared. Okay, now this is the lowercase sigma. It kind of looks like a curly R or an O with a top tail. Okay, so that is called the population variance. So there's the formula. Let's talk about what each of those means. Okay, the little curly squared stands for the population variance, equals, on top, the thing that looks like an E, a funny looking E, is the Greek letter sigma. Okay, there's uppercase and lower cases in Greek letters, just like we have. So the funny looking E is the Greek letter sigma, and it means to add. X just means numbers from the data. The mu, the funny looking curly M, is the Greek letter mu, and it stands for the population mean. The population mean is just the average. Capital N is the number of numbers for a population. It means how many numbers are in your set. Okay, so this is the formula for population variance, which means when you have everything. Another measure of variance is called the sample variance. Okay, it's very similar in the formula. The sample variance is when you only have part of the data. Okay, we're still measuring how close the numbers are. The symbol for sample variance is S squared. And here's the formula. It's very, very similar, except for some different variables. Okay, sigma, the E thing that looks like an E, is sigma, means to add. X still means the number from the data. X bar is the sample mean, which is the average. It's just a different symbol when we're talking about if it's a sample. Lowercase n is the number of numbers for a sample. Sample means we don't have all the data. Okay, and so that's the formula for sample variance. Okay, we're going to do some examples in another lesson, some actual number calculations. Right now I'm just going through the formulas. Okay, number 4, the population standard deviation. The symbol is the lowercase sigma without the square. So how do you find the population standard deviation? You take the variance of the population and take the square root of it. Okay, so what about the sample standard deviation? The symbol is S without the square. To take the sample standard deviation, you find the sample variance and then you take the square root of it. Okay, so how do you get the standard deviations? You take the variances and take the square root. Okay, there's a difference between population and sample in terms of which formula you use. Okay, now there are 5 parts that we're going to do for 3 different examples. Okay, so I've got examples 1, 2, and 3 with 3 different data sets, and we're going to do some calculation examples. For each of those 1, 2, and 3, find 5 things. Those 5 things listed there, A through E. Okay, the answers to these are going to be in a separate document. There's going to be a document for each of the 1, 2, 3. There's also going to be a video for each of the 1, 2, 3. So those will be in separate videos. How to do the calculations. This is the end of the notes for this section.